C# also introduces a set of logical patterns. This works very much like when you write an if statement that uses the operator and as well as the or operator. There is also a negation pattern. These different logical operations are called negated not, conjunctive and, disjunctive or. A good example of using the not pattern is together with the constant pattern where you check if an object is not null. You can easily state that if the order is not null, you'd enter the if statement. The not pattern can be applied in front of any pattern to negate it. While you could state that a Boolean value should not be false, it would most definitely be a better idea to state that you are looking for a Boolean that is true. If you have a property pattern that first checks if you have an instance, then goes ahead and check if the shipping provider's freight cost is more than 100, if you negate this using the not pattern, this have a bigger impact than you might imagine. It will in fact enter this expression if the order is null. Think of it like this. It tries to evaluate if the entire pattern is true, and then negates that. Be careful, as the code could quickly become hard to understand or have unexpected behaviors introduced. This is just like negation in any if statement. We've used another pattern a few times already without talking about what that is. I'm referring to the relational pattern. This is an extremely nice addition and a truly useful pattern. The relational pattern requires you to use a constant value to compare against the related value. If we head into the order extensions and look at generate report, we've used the relational pattern at a few places already. We've used it in the pattern that deconstructs the order to determine its status. Here, we looked for high priority orders by comparing the first value that comes out of the deconstruction with a constant value of 100. The relational pattern works with any relational operator. That is, greater than, less than, greater than or less than or equal. The constant value has to be a number, character, or enum. You're not limited to use the relational pattern with the deconstruction, or a tuple. It could, of course, be used with the property pattern as well. The relational pattern provides a good opportunity to introduce the pattern's conjunctive and, as well as disjunctive or. Doing so allow you to define a range. Let's say that we'd like to introduce another level of priority for the order status. To do this, we can add another case in the switch expression. Start off with the relational pattern. To define that this needs to be at least higher than 50, and then we'll apply a logical pattern using a conjunctive and. This means that it has to be more than 50 and less than or equal to 100. Finally, we'll say that the second value has to be true. Just because we've used the positional pattern previously in this switch expression doesn't necessarily mean that we have to do that for all the different cases. We could rewrite this to use the property pattern instead, just to see the difference. We'll access the property. Then for the property total, we can define that this needs to be more than 50 and less than or equals to 100. We can create an order and generate a report on an order where the total is 75. It should now say that this is a priority order. On the other hand, if we change the order total to 101, this would instead be a high priority order. You're not limited to just two values, and you could use this to exclude values in the range that you build a pattern for. While this doesn't make much sense for the total property, we could still give this a go and see how it works. Let's say that if the total is between 50 and 100, but not when it's 75, this is considered a priority order. This lets you exclude the constant value of 75 in relation to the property total. There's one more logical pattern. Since we've got a conjunctive and, there has to be a disjunctive or. Before we use this pattern, let's introduce a few subclasses of the order: a priority order, a shipped order, and a cancelled order. Now let's go back to where we generate the report and use these subclasses in our patterns. At this point, the patterns don't care about the type, as long as they can be deconstructed into something that matches the positional pattern, or if it has a property that matches the pattern we used with the property pattern. If a class is represented as a priority order, we may as well add that as a type pattern as well. If we simply add the type in front of the positional pattern, this would mean that it has to be of type priority order, as well as being deconstructed into what matches the positional pattern. This is effectively the same as adding an AND between the type and the positional pattern. How about if we'd like to say that the order is a priority if it's using the type priority order, or that it can be deconstructed into something that matches the positional pattern? This is where you can use the OR pattern. It's important to know that the pattern on the right-hand side of the OR is not necessarily going to be a priority order. Another important aspect is that when we use OR as well as NOT, you cannot declare a variable that the matched object will be stored in. Let's jump over to the program and give our new pattern a go. We'll construct an order and generate a report. If the total is above 100, we should still get this as a high priority order. This works just like the OR operator in an if statement. A problem with this switch expression is that it will match on a priority order or any type of order that simply has a value greater than 100 and is ready to be shipped. I'd like to express that this is either a priority order or a type of order that can be deconstructed into what we had earlier, but with an additional requirement. It cannot be cancelled or a shipped order. To do this, we are going to group the second pattern into what is known as a parenthesized pattern. This way, we can evaluate this entire group of patterns together. We'll start by wrapping the positional pattern with parentheses. And then we'll append patterns that has to be matched. Therefore, we'll use the conjunctive AND. This next part is very interesting. We'd like to define that the type is not a shipped order or cancelled. We can use the disjunctive OR to specify the two types we'd like to match on, and then negate that entire pattern. If we also add the named parameters to the positional pattern, this shows a complex pattern that is fairly easy to read and understand. We'd like to match on all priority orders, or orders that have a total value above 100, are ready to be shipped, and are not already shipped or cancelled orders. Expressing this using a traditional approach, wouldn't have been as easy on the eyes. Of course, this is starting to get a bit complex. And an easy approach in this case would have been to handle both the shipped and cancelled orders using a type pattern above this one. Even though this switch expression is getting a little bit complex and out of hand, it illustrates the power of pattern matching. You can combine a lot of different patterns and use it to express yourself in ways that have been a little bit more difficult before.